This lesson is an introduction to polynomials and introducing you to important terms. Let's begin with identifying what a variable is. A variable is a quantity whose value can change. Usually a variable is a letter of the alphabet in lowercase. For example, x, y, a, and b are common variables. So these variables, they have a numeric quantity, but we don't know what it is, and we represent it with a lowercase letter. An algebraic expression is a mathematical phrase made up of numbers and variables connected by addition or subtraction operators. So for example, 3x subtract 4 is an expression. 5x squared plus 3 is also an expression, as well as 7x squared subtract 2x plus 4. There is an important difference between an expression and an equation. So we just identified an expression. An expression is a phrase of numbers and variables connected between adding and subtracting operators, whereas an equation has values on either side of an equal sign. So there's expressions on the left side of an equal sign and also on the right side of an equal sign. In the box, it's asking us to label the variables. The variables are x here and x here. And it's asking us to label the algebraic expression. The algebraic expression is 3x plus 32, as well as 59 subtract x. They are both individual algebraic expressions. And we are to label the algebraic equation. This entire phrase, mathematical phrase, is an equation. It's separated by an equal sign. We have an algebraic expression on the left side and on the right side. A power is a product of identical factors and consists of two parts, a base and an exponent. So the base is the large number here, 2. And the exponent is the smaller number that's in the upper right corner. We call a base and an exponent together a power. So 2 cubed is 2 times 2 times 2. Okay, so in exponential form, we present it with an exponent. In expanded form, we write it out. What does 2 cubed actually mean? It means 2 times itself 3 times. Let's practice writing these powers in expanded form. 2 to the power of 5 is the same as 2 times 2 times 2 times 2 times 2, which is equal to 32. Notice that I'm not writing 2 times 2 times 2. Instead, I'm using brackets to represent multiplication. And that's because we are going to be using a lot of variables in this course, and variable x is very common. So multiplication, the multiplication sign and the variable x is very similar to each other. So I try to avoid using the multiplication sign as much as possible. Instead, I'll use brackets to represent multiplication so that I avoid as much confusion as possible. Next, negative 3 cubed. This is the same as negative 3 times negative 3 times negative 3. I'm going to simplify the first two negative 3's. So negative 3 times negative 3 is positive 9. And then we're going to multiply that by the last negative 3. So now we're multiplying a positive and a negative together. So my answer is going to be negative, and then 9 times 3 is 27. Next, negative 3 to the power of 4. An expanded form, that would be negative 3 times negative 3 times negative 3 times negative 3. Simplifying my two negative 3's together, that would equal to positive 9. And then negative 3 times negative 3 is equal to positive 9. And then positive 9 times positive 9 is equal to 81. Negative 3 to the power of 4. This is different than question C. In question C, the negative was inside the bracket with 3. In D, the negative is not in the bracket with 3. So in question C, the entire base is negative 3. So whatever the base is going to be multiplied by itself 4 times. Whereas in question D, the base here is only 3, and then it just happens to have a negative in front of it. We're going to multiply 3 by itself 4 times, and then we'll just add a negative in front of it. If the bracket is present and there is a negative sign in the bracket, that negative is included with the base. Okay, so the base is everything inside of the bracket and must be multiplied by itself however many times the exponent is. Okay, and in D, the base is just 3 and will multiply by itself 4 times and then add a negative in front of it. So this is the same as saying negative 3 times 3 times 3 times 3, which is equal to negative, and then 3 to the power of 4 is 81. Next, we have a decimal, which is fine. We're just going to multiply that base, 3.5, times itself 3 times. And we get a decimal. And then in F, we have a fraction. And again, that's okay too. We're just going to multiply the entire base, 2 over 3, times itself 3 times. And we know that when we're multiplying fractions, the numerators are going to be multiplied by each other, and then the denominators are going to be multiplied by each other. Okay, let's evaluate a few more questions here. So again, we need to be aware of when negatives are in brackets. Okay, so the entire base for A is negative 5. Not 5, negative 5. So this is equal to negative 5 times negative 5 times negative 5. And negative 5 times negative 5 times negative 5 is equal to negative 125. Okay, so when you're putting this in your calculator, make sure that you're including the brackets. So in your calculator, you're going to type in bracket, -5, close bracket, exponent 3. Or you're going to type in your calculator -5 times -5 times -5. The brackets are very important here to make sure that we are getting the base right. Let's look at B. In B, the negative is not part of the base. So the base here is just 5. So this is equal to -5 times 5 times 5, which is equal to negative, then 5 times 5 times 5 is 125. Next, -5 to the power of 4. Okay, so the entire base here is -5. So this is equal to -5 times -5 times -5 times -5, which is equal to 625. And finally, the base here is just 5. So this is equal to -5 times itself 4 times, which is equal to -5 to the power of 4, 625. And finally, we have a coefficient in front of our base. Our base here is -3. And we have a coefficient in front of our base. So the coefficient is a number that occurs in front of a bracket. We understand that this is 4 times whatever's in the bracket. The 4 is not included in the base. It's not inside the bracket. It's not included in the base. So the next line would be 4 times the following bedmass. We need to simplify what's in the bracket first. -3 times -3 times -3 is -27. And now we can multiply -27 by our coefficient, which is -108. Next, we are evaluating expressions by substituting given values. So wherever I see B, I'm going to substitute -6. And wherever I see H, I'm going to sub that with 3. So my next line is -6 squared times 3 subtract 3 times -6, which is equal to -6 times -6 is 36. Okay, following bedmass. Okay, and now I'm going to simplify 36 times 3, which is 108. Subtract 3 times -6 is -18. Now I'm going to simplify my double signs. So I want to simplify this. So 2 negatives will make a positive. The next line is going to be 108 plus 18, which is equal to 126. In B, wherever I see R, I'm going to sub that with 4. And wherever I see H, I'm going to sub it in with 10. Make sure you're using a scientific calculator instead of 3.14 when you're typing in your calculator. Okay, so 3.14 we've used in grade 8. It is an infinite number. It lasts forever. So we want to be as accurate as possible. So instead of just running it to 3.14, just click on that pi button that you have on the scientific calculator. I'm going to display this expression in a different way. And I'm going to show you here on the side. 1/3 pi r squared h is the same thing as saying 1/3 times pi times r squared times h. Okay, so instead of using the multiplication x sign here, and instead of using brackets, I'm going to represent multiplication with those periods. Okay, so when we have variables beside each other, it means that they're being multiplied by each other. Okay, pi r squared h means pi times r squared times h. Okay, another way of displaying this information is converting it all into fractions, because we do have a fraction 1/3. Every whole number has an invisible denominator of 1. So right now I'm converting all of my variables into a fraction. So they all have a denominator of 1. And now this is a multiplying fractions question. All of my numerators I can multiply together. And then all of my denominators I can multiply together. My numerator will be pi r squared h divided by my denominator is 3. We have a fraction 1/3 and then pi r squared h all multiplied together. I've just rewritten it now as one big fraction, pi r squared h all divided by 3. I've done this to make the presentation of our expression a little bit easier to read. So now, when I'm going to sub in my values into my new presentation, my numerator is going to be pi times 4 squared times 10, all divided by 3. I'm going to simplify my numerator. So pi will stay the same. 4 squared will simplify to 16 times 10 divided by 3. And then this is all multiplication in my numerator. So just plugging that into my calculator, pi times 16 times 10. And I'm going to round it. I'm going to put a dot on top of the equal sign, which represents approximately 502.65 divided by 3, which is equal to approximately 107.55. So here's a word problem. Joe thinks that -4 cubed is equal to 12. Is he right or wrong? Well, let's see. -4 cubed. Our base is 4, not -4, because it's not in brackets. So this is equal to -4 times itself 3 times, which is equal to -4 cubed is 64. So I think what Joe did here was, I think he multiplied the exponent. So I think he multiplied 4 times 3 to get 12 instead of multiplying 4 by itself 3 times. Moving on, let's look at the expression 4x squared. This is called a term. A term consists of 2 parts. We have the variable and its exponent, and then a coefficient, which is the number in front of the variable. Together, it looks like this, 4x squared. Let's look at some examples here and identify the coefficient and variables within the term. In words, Jim earns $7 per hour at his part-time job. If he works for X hours, his earnings in dollars are 7x. So here's the expression. It's also a term. The coefficient is 7, and the variable is x. Next, the depth in meters of a falling stone in a well after t seconds is negative 4.9 t squared. So the coefficient is both the negative and the decimal, everything in front of t, and the variable here is t. T is being squared, but the variable is t. Next, the area of a triangle with base b and height h is 1/2 times base times height. So the expression is 1/2 bh. The coefficient here is 1/2, and there are two variables, b and h. Next, the area of a square with side length k is k squared. Every variable has a coefficient in front of it. If it's not written like this k, there's no coefficient in front of it, we understand that there is an invisible 1 in front of it. So the coefficient here is 1, and the variable is k. Finally, Amir walks 6 blocks to school. So the coefficient here is 6, and there are no variables attached to it. Okay, so when there is no visible coefficient in front of a variable, the coefficient is 1. When there is no variable part of a term, we refer to the term as a constant term. For example, here, the term is just 6. So the coefficient is 6, but there is no variable attached to it. So instead of calling it coefficient 6, we actually just call it a constant. It does not have a variable attached to it. When you are asked to state the variable of a term, the exponent is not part of the variable. And we saw that in part B and in part D, where the variable was just t, not t squared. And here the variable was k, not k squared. A polynomial can be classified by the number of terms it has. So here are 3 different types of polynomials. We have a monomial, binomial, and trinomial. Mono means 1. Bi means 2. And tri means 3. So in a monomial, there's only going to be one term. For example, x, 3x, negative 4a squared, 5. These are all monomials. In a binomial, you're going to get 2 terms. So 2x subtract 3. They are 2 terms in one expression. I know that these are 2 terms because they are separated by either an addition or a subtraction sign. So 2x is one term, and then negative 3 is a second term. So try not to get confused with the subtraction and the negative sign. I've said this before that this is now a subtraction sign, but also it belongs to this term 3. So it's not actually, this term is not actually 3, it's negative 3. We can read this as 2x subtract 3, or we can read them as individual terms, 2x, negative 3. 2 separate terms in this expression. Next, we have AB plus 2A. Or we can read it as AB positive 2A. Still binomials, still 2 terms in the expression. And then 0.4x squared is one term, and then negative x is a second term. And then some examples of trinomials, 3 terms in the expression. Here's 1, 2, 3 terms. And 1, 2, 3 terms. For polynomials with more than 3 terms, you can classify them as a blank term polynomial, where you would fill in the blank with the number of terms. So for example, a plus b plus c plus d plus e, those are 5, that's a 5-term polynomial. So we would just insert the number of terms into the blank here. Let's practice classifying polynomials by name. So we have 3x squared plus 2x. So we have 1, 2 terms. We would call this a binomial. Next, negative 2m. This is 1 term, so we would call it a monomial. Next, 4x squared subtract 3xy plus y squared. 3 terms, we call this a trinomial. Finally, a subtract 2b plus c subtract 3. 4 terms, we would call this a 4-term polynomial. There are some homework questions for you to complete independently. There is a PDF copy of a workbook attached on Google Classroom, so check that out. I also provided you with the answer key, so make sure that you are checking your answers to ensure that you have all the correct answers and that you fully understand before moving on to the next part of this lesson. Collecting like terms. Like terms are terms that have the exact same variables with the exact same exponents. Okay, so they need to have the same variable and the same exponent attached to that variable. So examples of like terms, 2x and 7x are like terms. They have different coefficients, but that doesn't matter. What's important is that they share the same variable x. Okay, 3x squared y and 5x squared y are also like terms because they both have an x squared and a y. Okay, unlike terms, x and x squared are not like. They don't have the same exponents. And 3x squared y is not the same as xy squared. The x has to have the same exponent and the y has to have the same exponent. Let's practice identifying like terms in each group. So in the first group, like terms are 2x, 8x, 3x, 3x. They all have variable x. In B, like terms are 4a squared and negative a squared. They both have variable a squared. And finally, 3u squared and 2u squared are like. They both have variable u squared, as well as 6 and negative 5 are like because they're both constants. To simplify a polynomial expression, add or subtract like terms by adding the coefficients and keeping the variable the same. To simplify an expression is to find an equivalent, simpler, and shorter expression. Let's practice adding like terms. These are like terms in question A. They both have the x variable. So to add like terms, I'm going to write my like variable once, and then I'm going to just add the coefficients. So 4 and 3 I'm going to add together. 4 plus 3 is 7. So 4x plus 3x is equal to 7x. In B, the first thing I'm going to do is I'm going to collect like terms. I want my x terms to be beside each other, and I want my constants to be beside each other. So I'm going to rewrite my 4x and 2x to be beside each other, and then my 3 and my 5 to be beside each other. And then in my next line, I'm going to simplify my like terms. So remember, 4x and 2x can be simplified together. So I'm going to keep the variable the same and add my coefficients together. And then I'm going to simplify my constants together. I can't simplify any further from this because 6x and 8 are not like terms. So I'm finished at this point. Let's practice subtracting like terms. So 8x minus 3x, I'm going to keep the variable the same and subtract my coefficients. In B, I'm going to first collect like terms. My like terms are 5x squared and negative 3x squared. So I'm going to write them beside each other in my next line. And then negative 2x is like with negative 9x. So I'm going to write them together. And then I'm going to simplify like terms. I can only simplify my x squared terms together, and I can only simplify my x terms together. Adding and subtracting to simplify algebraic expressions is called collecting like terms, which I already introduced you to that term on the previous page, but we're just going to practice collecting like terms and simplifying like terms here again. So my like terms for A is 6x and 8x. So by collecting like terms, I'm just writing them beside each other on the next line. And 4 and 3 are constants, so I'm going to write them beside each other as they are like terms. And then I can simplify. 6x plus 8x is 14x. 4 plus 3 is 7. I can't simplify any further because 14x and 7 are not like terms. In B, my like terms are already collected. They're already written beside each other. So all I have to do is just simplify. And remember that this is subtract 1b. Okay, there's an invisible 1 in front of it. So 2 subtract 1 is 1b. And I'm just going to write b and not 1b because I understand that b has that invisible 1 in front of it. So I don't need to write it. And then 7 subtract 8 is negative 1. C, I'm going to write my like terms beside each other. So my r squared terms are beside each other, then my r terms are next to each other, and then my constant is at the end. So 3r squared subtract 3r squared, it actually just cancels itself out. So let's move on to my r terms. Negative 6 plus 9 is 3r. Then I'm just going to rewrite my constant. Again, there's nothing to simplify it with, so I'm just going to write it at the end. And then D, these are decimals, which is fine. What's important is the variables. That's going to identify whether or not they're like or not. So I'm going to write all my m terms beside each other. And then all my n terms beside each other. And then my constant at the end. So my m terms will simplify to 1.2, m. And then negative 4.5 plus 4.5 will cancel itself out. And then I'm just going to rewrite my constant at the end. Let's practice a word problem. A rectangular field has a length that is 8 times its width. Draw a labeled diagram of the field. Let W represent the width of the field. So here's my field, and it says that the length is 8 times the width. So if this is my length and this is my width, I know that my length is 8 widths. So instead of writing L and W, I'm going to write 8W and W. Write an expression for the perimeter of the field. So we know that the perimeter is equal to all the side lengths added together. So instead of writing length plus width plus width, I'm going to write length as 8W. So 8W plus 8W plus width plus width. And these are all like terms. 8W, 8W, W, and W are all like. So I can simplify that. 8 plus 8 plus 1 plus 1 is 18W. Find the perimeter of the field if it is 500 meters wide. So the perimeter we found is 18W. So it's giving me the value of W. It's saying that W is equal to 500. So now, where I see W, I'm going to sub for 500. So the perimeter is equal to 18 times 500. Perimeter is equal to 9,000. Therefore, if the width is 500 meters, the perimeter of the field is 9,000 meters. There are some homework questions to practice the second half of this lesson. You'll find it in the workbook PDF that is posted on our Google Classroom. If you have any questions about today's lesson, please join the Zoom, or you may private message me or email me at any time.